Not surprisingly, scientists and engineers began looking for a better way to separate isotopes, and work continues to this day. One of the next methods brought into production was the use of gas centrifuges. The gas centrifuge uranium enrichment process uses a large number of rotating cylinders in series and parallel formations. Centrifuge machines are interconnected to form trains and cascades. In this process, UF6 gas is fed into a cylinder, rotating at high speed. This rotation creates a strong centrifugal force so that the heavier gas molecules containing uranium-238 move toward the outside of the cylinder, and the lighter gas molecules containing U-235 collect closer to the center. The stream that is slightly enriched in U-235 is withdrawn and fed to the next higher stage, while the slightly depleted stream is recycled back into the next lower stage, much the same as with the gas diffusion plant. Significantly more U-235 enrichment can be obtained from a single unit gas centrifuge than from a single unit gaseous diffusion stage, however. Alpha equals 1.3 for gas centrifuges versus alpha equals 1.0043 for gas diffusion units, but both of these are theoretical values. With this higher enrichment factor, far fewer stages are needed for a given product enrichment. The next figure shows a gas centrifuge cascade for 4% and 90% product enrichments. Compare this to gas diffusion, which takes 1,225 stages for 4% enrichment and 3,725 stages for 90% enrichment. It is this and other advanced isotope separation techniques that worry us about rogue nations being able to produce nuclear weapon material. On the other hand, don't be misled. The centrifuges are without their own set of challenges. Although the stage separation factor is wonderful, the throughput is small compared to diffusion units. So many centrifuges are needed in each parallel train across the cascade. Unlike diffusion units, centrifuges have moving parts and therefore can break down, sometimes catastrophically. One of the concerns is that the shrapnel from one failure would damage other units, causing another kind of cascade effect that we don't want. Looking at the figure again, we see that roughly 10,000 centrifuges are used in the cascade. If the mean time to failure was 10 years, only 3 centrifuges per day would fail. Obviously, high reliability is of utmost importance.